Hey guys, Shawn Brown here from SBSolo, and guess what? Practical Machinist gave me my own series called How We Do It. I'm not sure what they're thinking. I don't want to let them down though, so we're going to go through pretty much every practical way we can make a part, fixture, spit parts out of the vise. Hopefully we don't do that, but if I do, I'm going to show it, and then we're going to show why it happened, and let's not do it again. So I think this first part, let's do a 2-operation part, super simple. I'm going to go through in my brain how we do it, and hopefully it's not too confusing and I don't confuse myself along the way. So without further ado, let's just get into it. All right guys, so this is the part we're going to be making. It is round and it can either go on a mill or a live tooling lathe. I chose to do it on my mill, and there's a reason for that. The main reason is that it's 3 inches in diameter, and my live tooling lathe only has a 2 3/8 or 2 5/8 spindle liner through. So I would have to get these individually cut out of a bar like pucks and then load them in, and that cost, I don't have a saw, so that cost to me is way higher than if I actually got flat bar and had them cut. So that was a choice I made, and plus the lathe was busy. All right, so this is the material stock around the part. As you can see, that this is 3-inch bar stock, and I'll have it cut to 3.125 because the part itself is 2.9785, so it's just under 3 inches. My rule of thumb on smaller parts, or just most parts, is that I go 75 thou per side extra cut, so basically it's 150 thou extra over the nominal size of the part. I do that because I've never had any problems with my saw supplier. When they cut, they actually use a cold saw, so it's very square. I mean, you have to kind of go with what your saw supplier has. Sometimes they use band saws, which aren't as square, but what they'll do is they'll do usually 0 to 100 thou over what you spec out. So if I do 150 thou over, which gives me 75 a side, they're either going to be 0 to 100 over. So it gives me plenty enough room to clean up. Never had a problem with that, but that's kind of my thought on how I pick what size to have it sawn at. All right, so what we have here is a couple tool paths. We're basically roughing around it. We're roughing the pocket out and roughing the center. I duplicated it up because I have a double station vise, and it's finishing. I kind of just wanted to show you this a little bit. All right, so let's verify this thing so you guys can see what's going on here. Roughed it, finished top, O-ring. It's putting some holes in there with countersinks, and then yeah, we have the thread in the middle. So that is what we're going to make on the mill right now. So let's just jump in the mill and get right into it. All right, you guys, so I'm going to run my GoPro. It's going to be a little bit easier to see. So this is what we're going to do. I'm going to take these 2 pieces of material. I'm going to throw them in this vise. I'm going to do 2 at a time, even though I only showed you 1 on the verifier. I line them up to the edge here, and then I clamp them down, and I clamp them down tight. And then I release, and then reclamp. Now the reason why I do that is if you look, it's got little impressions. So you can see the teeth on there that it gave the imprint. So if I put this back, I can feel it, like you can feel it like catch. So I can replace this and then recut if I wanted to, and it can repeat probably within a thou. It's going to have enough grip force to not rip out while I have it kind of snug, because we don't want to bow the part. The part could get, I mean, it's fairly thick, kind of short, but the longer the plate, it could bow the part out. All right, I can show you what I mean. I'll put this on here. So if I clamp this in here and tighten this to where I don't think it'll pull out, you're almost about 2/1000ths, but if I release, and now that I got those grooves in there, I can lightly tighten it, and I can barely 5/10ths out of it. So I just remember what kind of tension that is on my vise handle, and I kind of put it in my memory. You can use a torque wrench, and that'll work totally fine, but if you use multiple vices, using a torque wrench doesn't always work, because each vise, if the gib is different or it's not maintenance, they'll always clamp a little bit different. Yeah, so let's get to machine this thing. All right, tool number 1, we're going to rough it. Just doing a dynamic tool path right now. So I'm using my old machine, and in doing so, I actually use the rapid to jump over the part a little more, because it can't handle the dynamic movements if I keep the tool down. It's not the best situation, so usually when I program for the weakest link if I know they're going to go on both machines. Woo! Almost lost the tool right there. It doesn't like ramping without coolant, that's for sure. So tool 2 is a finisher. It's gonna go around the outside. If I have to go into soft jaws for the next operation, I always make a sprint cut on the outside, just so it grabs a hold nice. Now we'll cut the counter bore. So now we're cutting the minor of the thread. I'm counterboring the countersink holes because they have a little bit of counterbore on top of the countersink. I don't want to just jam my countersink in there and hope that it cuts, and it just leaves a horrible finish. So we'll go in there with an end mill first, and then we'll come in with the chamfer mill. I could probably go faster on this toolpath, but usually when I prove something out, even though I proved this out, I just did it, and I don't necessarily worry too much about feeds and speeds until I have it locked down, as far as like the part is locked down nice. So right now I am running the O-ring. I'm gonna have to use coolant on this. Hopefully it doesn't break. A little dark in there. So I use a chamfer mill to actually do my countersinks, a 90-degree chamfer mill. That way I can chamfer the edges like this and do countersinks with it as well. Drill a few holes. So this is the thread mill doing its work. All right, so I had to put threads in here, and the company that I'm doing this for, I have the male piece. If you don't have the male piece, you'll have to make yourself a plug gauge. They may be okay with just using the male piece here. It screws right in there. And yeah, but most of the time you're probably gonna have to get a plug gauge. This isn't super critical, so what I did actually is I machined myself a plug gauge. Can you see that? Let me move out of the way here. So what I did was I actually machined myself a plug gauge on my lathe. So I have a no-go and a go. Go. Goes. All good. And then no-go doesn't go. So that's how you check the threads. You either have a plug gauge, or if you're the company you're doing work for is okay with using the male counterpart, then that's good. But I ended up making this anyway. It's out of 303. It's all I had in stock. If I was going to make it like to last, I'd probably use like 17.4 or something, like something harder. But yeah, so there you go. Maybe I'll make a video on how to make a plug gauge on a lathe. Be a good little episode, I think. So I know a few of you guys saw that the drill went in after my countersink, and then I didn't even spot it. I just punched it, and it hit the edges of the drill is what's happening, because my countersink is 90 degrees, and my drill is 135 degrees, so the edges are going to hit first and not center up properly. If it was steel, all day long, spot it with 140 degree, but with aluminum, I've never had a problem with that. I could probably hold within 2 to 3 thousandths easily on position doing it that way, and the drills never wear out. That's the beauty of aluminum. You kind of like have, you can pretty much do anything with aluminum, but I don't suggest ever doing that with steel or anything like that. But that being said, I'll show you the tolerance that I got out of this just by drilling it. All right, so let's see, we've got 1.211, 1.210 and a half, 1.211. So you can see that it's actually pretty accurate just drilling through the countersink and not having a spot face. Definitely need to do that on steel. But aluminum, I do this all the time and I don't ever have a problem with it, and the drills look pretty good. So I know some of you guys are gonna comment on there like, whoa, 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 whoa. That's not how you do that. Typically no, but in this case it does work. All right, so Op1 is done. And to do Op2, I've elected to use soft jaws. It's the easiest way to do it. And so I've already cut my soft jaws, but there's a couple things I want to show you on these soft jaws. So you could actually cut out a diameter inside your soft jaws that are the same size as the diameter of this, put it in here, clamp it tight, it should be good to go. But what I do on these soft jaws is I actually bumped out the top quadrant, top and bottom quadrant, and the left and right quadrant, so that way it doesn't clamp on the high point. Because if this was a little smaller and your jaws were a little bigger, it would actually grab here and kind of want to pivot out of the vise. So it's like grabbing like this, and it could pop out. So if I cut a relief on the top, it actually now has 2 points of contact on the top and 2 points of contact on the bottom. So that way when it pinches, you're kind of pinching more in a cross pattern. Not so much, it's not that big, but you know, you're not just pinching on one point right there, and then it'll give you a little more grip force with less clamping pressure. You know, maybe down the road we'll do a whole video of custom soft jaws, which would be pretty cool. There's a lot that goes into soft jaws. So just one more video that we can do in the series. All right, let's throw these jaws in, and then we'll start cutting op 2. Okay, jaws are in. Let's throw these parts in here. I'm just eyeballing them. See that? You see that right there? That's how we do it. Yeah, I'm gonna have to hide that one from the boss. it's messed up. All right, so we're putting them in there square, and I'll lightly clamp it. I'll give it a little tap. I don't know if you heard that, but it kind of tinged, and that tells me that it didn't sit flat. And the reason why, you don't always have to tap your parts, but if you want them flat, you can. It's a good indicator if it's actually lifted off the vise. Now, if I hit this really hard, it could bounce back off the soft jaws and kick back up. So I got to do it. I kind of just listen to it, and then I give it a little bit more of a snug, and it should be pretty good. But that's the reason why I use a hammer, is that it kind of keeps it, you know, on the deck. You can hear it hit the deck, and I'm just listening for a noise. Maybe I have a chip underneath it, and if I tap it, it's going to be kind of hollow sounding, tingy sounding. So I'll pull it back out. So it's kind of a good indicator. It's not always needed, but you know, in this case, I want them fairly flat, so that's why I'm using it. All right, there we go. All locked in there, ready to go. Now let's get through op 2. So right now we're roughing all the way around the outside, all the way to the boss. So this is a bull nose mill with a 30 thou radius. So when it hits that boss, it'll have a fillet, a 30 thou fillet at the bottom there. Deck the top. Now we're gonna go in and chamfer the center. That's all there is, okay. So this is a quarter rounder, 062 corner rounder. Just cutting the top fillet and the outside fillet. And that's it. And there is the finished part. A few techniques thrown in there for a simple part to make it a little bit flatter. It's pretty good. Ship it. Oh man, we made it through episode 1 of how we do it. And I only dropped it once. And I told you guys if I did a screw up, I was going to put it on the film. So yeah, anything goes, all right? So I hope you guys learned something. Pretty easy part, but I threw a few things in there that maybe some of you have learned. And yeah, if you want to see more, you know where to find me. Practical Machinist YouTube channel, and then IG, Practical Machinist. So until next time, let's go.